Hey there, physics fans. Today we're going to talk about the linearization of experiments and why we concern ourselves with it. Refer to Appendix I of your SLAM for more details than are discussed in this video. First off, let's recall what we mean when we say we have a linear relationship. A linear equation takes the form of y equals mx plus b, where x is the independent quantity and y is the dependent quantity. If there is a linear relationship between the independent and dependent quantities, then an experiment where we change the independent quantity will yield a linearly proportional change in the dependent quantity. This allows us to apply physics concepts, predict results, and evaluate outcomes of many different types of experiments. A linearized experiment also allows for the experimental determination of an objective quantity that is a factor in the slope of the linear relationship. This can provide more accuracy and precision than a single measurement experiment. Through linear regression analysis, we can also determine the absolute uncertainty for our objective quantity. This process mitigates some types of systematic and random errors. The linearization process includes 10 steps outlined in the SLAM. We'll generally go over them in this video. For steps 1 and 2, you're going to apply physics in order to determine an algebraic expression that includes your independent variable and your dependent variable. Next, you're going to rearrange the equation so that it's in the y equals mx plus b form, where the independent variable is on the right-hand side of the equation and the dependent variable is isolated on the left-hand side of the equation. I recommend that you not only isolate the independent quantity on the right-hand side of the equation, but also draw parentheses around it so that it better reflects the linear equation. Next, you're going to identify your independent quantity, your dependent quantity, the objective, and your control variables. Next, you're going to write an expression for your slope in terms of the objective and control variables. Next, you'll rearrange that equation so that you have the objective isolated on the left-hand side of the equation. Now you are ready to conduct your experiment. Take data where you vary the independent variable and measure the dependent variable. Plot your data so that the independent quantity is on the x-axis and the dependent quantity is on the y-axis. If everything is done right, you should see a linear relationship on your graph. And now you can conduct linear regression analysis with your plotted data. This provides the slope and its absolute uncertainty. You'll use the value of the slope to determine the magnitude of your objective using the equation from step 8. You'll use the slope's absolute uncertainty to propagate your experimental error so that you can determine the absolute uncertainty of the objective quantity. I recommend that you watch our video on the propagation of error for more information on step 10. Until next time, physics fans, and remember, read the SLAM.